Welcome to this set of lectures on biomolecules and their relationship to the cell structure and function, which are important aspects. We will go through a set of lectures which will cover appropriately sized, so that it will be easy for you to assimilate aspects. Okay, let us ask the question, why are instruments sterilized before an operation? What I mean by an operation is a surgical procedure. Why are instruments sterilized before the medical doctor cuts open the skin? All of us would know the answer to this question: to avoid infection. Okay. What causes infection? Okay. And how does sterilization help in preventing infection? These would be the natural questions that come about, right. What causes infection? Let us answer that first. Infection is caused by microorganisms such as bacteria, fungi and so on. Okay. I should say some types of microorganisms among bacteria, fungi. There are a lot of very useful types of bacteria, fungi which actually reside inside our body and do a lot of useful things for us. Okay. We should not forget that aspect. So, there are harmful bacteria, harmful fungi, viruses and so on, and they can, in terms of infection, let us stick to bacteria and fungi, they can cause a lot of infection, right. And to where is this bacteria and why should it cause infection when the surgeon is making an incision in the skin? That is because these microorganisms, bacteria and other such organisms are in the air around us. Studies have found that about 10 power 3 to 10 power 4, 1000 to 10,000 bacterium per milliliter, okay, per cc, per cubic centimeter, are present in the air around us. They are present all the time, right, and they are interacting with us all the time. Our body has immune system which fights against this all the time, and as long as this balance is maintained, we do not get infection. Okay. Whereas, when the surgeon is operating and when the surgeon is making an incision in the skin, if there are bacteria around, it will start settling in this wound and that will cause infection. Okay. So, conditions need to be created such that there is not much bacteria around, not much bacteria on the tables, in the material that is in the operation theatre, certainly not in the instruments and so on. Okay. So, such things need to be taken into account. It is also a nice exercise to carry out to realize how much of bacteria is present around. I did mention 10 power 3 to 10 power 4 organisms per ml. You may want to do this calculation, find out the mass of air in the room that you are sitting in. Okay, you will be in for a surprise. Okay. The density of air is 1.29 kilogram per meter cubed. If you would need that to make an estimate, you would be very surprised as to the mass of air that is just present in the room that you are sitting. Why don't you do that? Okay. Now, what is bacteria? Bacteria, it could be something like this. If you look at it under the microscope, you see these rod shaped structures here. This could be one of the bacteria that is present in nature. There could be other kinds of bacteria that are present with different shapes, slightly different size and so on and so forth. And there are so many different kinds of bacteria. They are different in fundamental ways. We will come to know what those fundamental ways are to a certain extent when we go through the course. They are different in many fundamental ways from the other life forms. Okay. And it is so different and it is so big that bacteria is one of the 3 major domains of life. Okay. Before I go forward, I should acknowledge that some of the figures in this course have been adapted by Anushri Santosh and Sujin Raj. Now, let us get back to domains. Life, bacteria is one of the domains. The other major domain is archaea, and eukarya is the third major domain. Okay. This is what I call as domain. There are three major domains in life, and each domain has many kingdoms. Each kingdom has many phyla, phylum plural, phylum singular, phyla plural. Each phylum has many classes, each class has many orders, each order has many families, each family has many genuses, and each genus has many species. Okay. Do not worry about this, I will give you a mnemonic which I picked up from one of the videos that I am going to suggest to you. I think it is the mnemonic is, do koalas prefer cheese or fruit generally speaking? Yeah, do koalas prefer cheese or fruit generally speaking? Let us have it that way. Okay. There is a way to remember this. Anyway, if you look at these videos, there are two videos that I would like to recommend. The first one you can, it's a small video you can watch. Please ignore the terms, they will talk of DNA, RNA and so on and so forth. Please do not worry about the terms, we will know what those terms are only as a part of this course, if you do not already know them. If you know them, then it is fine. And the second video is slightly longer, about you could watch about 3/5 of that video, the rest gets into too much detail, and this would tell you all about the domains of life and some of these aspects also. Okay. Then life itself is made up of cells, either single cells as in the case of archaea, bacteria and some protists in the eukarya family, or it could be made up of multiple cells such as some fungi, mushrooms and so on and so forth, they are fungi, animals of course, plants, humans and so on. Okay. So, life is made up of either single cells or an organization of single cells. Can anybody guess the number of cells in the human body? It is of the order of about 10 power 14, okay, 10 power 14. So, you can imagine the number of cells and how they interact with each other to make life possible. There are two major types of cells. First type is called prokaryote, the second type is called eukaryote. What do these names mean? If you know the name, if you know the meaning of the names, probably it is a little easier to get more comfortable. It so happens karyon means nucleus, karyon is the word for nucleus, pro is before, this we all know, eu means true. Okay. So, prokaryote before nucleus, eukaryote something that has a true nucleus, that is what it means. This is a prokaryotic cell, a simple enough cell here, typically small, we will come to sizes in a minute. It has some parts, okay, let us not get too much into it. It is of course separated from its environment through a cellular envelope that could have a cell wall and a cell membrane. It could have some DNA kind of strewn around here in the cell, which is not limited in any way physically in the cell, and this is prokaryote before nucleus. There is no well defined nucleus in a prokaryotic cell, whereas in a eukaryotic cell it is complex, it has a well defined nucleus that contains many things including DNA, right. This is a basic difference. A eukaryotic cell has a true nucleus, a prokaryotic cell does not have a well defined nucleus. This is a well defined nucleus. Okay. This has a membrane, and inside the membrane whatever is there is called the cytoplasm, and in the cytoplasm you have a lot of organelles, small things that have, each one has their own function, and of course, the nucleus is here indicated here, which contains DNA and other things. Okay. So, this is good enough to know. The typical sizes, a prokaryotic cell, for example, a bacterial cell is about 5 microns typical size, okay, 5 micron length, 2 micron diameter, or if it is spherical, it could probably be about 5 micron diameter, and so on. Many prokaryotic cells are of that size, typically speaking. There are variations, of course, but we are talking of some typical sizes here. Whereas a eukaryotic cell could be of a typical size. A mammalian cell, for example, could be of 10 micron diameter, typical size. Even a human cell goes anywhere from 7 microns to about 12 to 14 microns during its lifetime, right. So, there is variation with time in the cell size also, but we are talking of typical sizes. If we talk of fungi, which are eukaryotes, that could be a few microns in size, fungal cell. If you talk of mold, you cannot really talk of a single cell in the mold because it branches and so on and so forth. Let us not get into that. You just need to kind of have this in the background, saying that the cells are not separated from each other. If you talk of a neuron, which is a neural cell in humans, that could be 200 microns, right. So, it widely varies, the cell size widely varies. Typical sizes about 2 to 5 microns, this is about 10 microns. These are good enough for our back of the envelope calculations. Why are we so interested in this cell? Because cell is the fundamental functional unit of life. What does it mean? If we understand the cell and all its functions, all its properties, then we would be able to somewhat predict what happens to life. Okay, that is what it means. Same way that a unit cell in, let us say, crystal structure, the properties, with those properties you could predict properties of the whole thing and so on and so forth. This is some fundamental unit of life itself. It is the biological cell. That is why we are so interested in the cell. As I mentioned earlier, these organisms, remember we are talking, our story is about infection in during surgeries, how to prevent them and so on and so forth. Let us stick to that story. The organisms are present everywhere, the harmful organisms are also present everywhere, and to get rid of these organisms in the place of interest, which happens to be the operation theatre, the instruments which are used to cut the skin and so on, we need to sterilize them, right. How are instruments sterilized? How is an operations theatre sterilized? Instrument sterilization, it is rather straightforward. So, let me talk about that first, and then we will get to the operation theatre sterilization, which is a whole field in itself. Instruments are sterilized by exposing the metallic instruments to high temperature and keeping it at high temperature over a certain period of time. The standard way of sterilization, autoclaving as it is called. So, the temperature is raised to about 121 degrees C, steam is used. As we all know, thermodynamics, steam, 121 degrees C, you need a higher pressure to maintain the conditions there. So, you have slightly higher than atmospheric pressure conditions in the autoclave. So, you create such conditions and you keep it at that condition 121 degrees C at say 1.2 atmospheres for about 15 minutes. It kills these cells as well as kills the spores and so on and so forth. Okay. So, that is a very standard method of sterilizing instruments, of sterilizing things that we use in the lab to grow organisms and so on. So, instruments are sterilized that way. But how do you sterilize operation theatres, okay, which are huge spaces? How do we sterilize labs, which are huge spaces? In the labs you would want to grow only the cells that we are interested in. We do not want the others to grow and compete for the food that is given to the cells of interest. Right? How is this done? Okay. It is very interesting the way it is done. It is done by using chemical vapors, okay. And the procedure that I am going to described now is used heavily in labs, because you can control the conditions there and kind of not let people enter the lab very strictly and so on and so forth. You have a control over that, and therefore you could do that. Okay. You will have to be careful if you are dealing with people and you want to use this procedure. It is not very safe. There could be related methods that are safer, but which are a lot more elaborate to use. The cells are killed by formaldehyde, okay, HCHO, formaldehyde, and the formaldehyde vapor is generated from what are called formalin solutions. Formalin solution is nothing but 40% formaldehyde in water. Okay, this you get, you can buy it off the shelf. So, what people normally do, let me describe the lab procedure here. First, all the windows and doors are sealed except the passage through, or the door through which you need to get out, and then we use what are called aluminum boats, in which we have this formalin solution, 40% formaldehyde solution. This is in the liquid. Okay. This has to come out into the vapor to kill all the organisms in the space in the lab, so that the space is made clean, or space is made clear of these microorganisms that are present there. And to make that possible, to generate formaldehyde vapors, what is used is the exothermic reaction between potassium permanganate and the formalin solution. Okay. So, these aluminum boats containing formalin solutions are placed in key positions in the lab, then everybody is sent out, and before you place the formalin solution, make sure that it is made sure that all the windows and doors are shut and taped, so that no vapor escapes out, because this vapor is poisonous. And then the person uses a mask and so on, just for those few seconds, drops a few pellets of potassium permanganate that are carefully weighed out for, required for the stoichiometric release of formaldehyde and so on, drops in the aluminum boats farthest first, and then keeps dropping in the boats that are closer to the door, and then quickly walks out the door, shuts the lab and tapes the door shut. Okay. It is left there for a day or two, and maybe a day more, just to make sure that none of the vapors are present, and then somebody gets in and neutralizes the present formaldehyde and so on and so forth. Okay. So, it is an elaborate procedure that is used to sterilize the lab. We do it from time to time, maybe once in a month or so. It is recommended that the lab be sterilized. A similar procedure can be used for operation theatres. It has been used for operation theatres, but in addition you could swab with, let us say, 70% ethanol. You could use other cleaning solutions, mop the floors and so on and so forth. That is normally done. Okay. That is how the space is gotten rid of these microorganisms, the microorganisms, some of which have the capability to cause infection in humans. Okay. That is how an operation theatre is sterilized, how the instruments are sterilized. How is a bioreactor sterilized? Okay. And you would go, okay, where is this bioreactor coming from? Okay. So, this question before that, what is a bioreactor? Okay. This is something that people normally used from an engineering perspective, so I thought it will be closer to you. Bioreactor, by the way, it is certainly closer to me. This is the area in which I used to work heavily. Bioreactor is a vessel, any vessel, in which bioproducts are made. It is as simple as that. It is something that is used for production, that uses organisms for production. These organisms produce many useful compounds, many useful substances, including a lot of medicines. For example, if you see this figure, I think this is a video, YouTube, it is a video, it will tell you how a single use bioreactor looks like and what it is used for and so on. Bioreactors could be very large, extremely large, because of the use in production of high volume products. Okay. and this link here gives you an image of one such large bioreactor. And many of these water treatment facilities have bioreactors that are large. Okay. Bioreactors are the basal ones that are used for water treatment, they are very large too. The bioreactor is a part, an important part of what is called a bioprocess, and the bioprocess is the one that is used to produce all these products of interest to us. There are very many products, we will see some of those products in this course itself. Okay. We have for a bioprocess the bioreactor aspect and what is called the downstream processing aspect. In fact, the downstream processing part could have about 90% of the steps of this bioprocess. Bioreactor is a small part of it, okay, but it is kind of a central part. Raw material goes into the bioreactor either in a continuous fashion or in a batch fashion, you dump everything at one time. And in the bioreactor you have the microorganism of interest along with the nutrients for it to grow and make the product, or there could be an enzyme that is present. Okay. Just take the name on its face value. Now you might have heard of enzymes. We will actually look at what enzymes are in detail in this course, okay, or an enzyme here, either microorganism plus nutrients or an enzyme, and the raw material is converted into the product of interest. So what comes out of the bioreactor is a mixture of the product of interest, the microorganism that is there which is producing the product, and a lot of other material which is present in the nutrients, the medium as it is called, and so on. And maybe some other products are also produced which may not be of much interest to us. We are interested only in the product of great importance to us amongst the products that are present. So this product needs to be separated out from all this to be able for its proper use, and that is done by what are called the downstream processing steps. A large number of steps including distillation, extraction, and so on and so forth, till we get the final purified product. Okay. This is what the bioprocess is. The bioprocess produces a lot of useful substances, and in the bioreactor these cells that we talked about, the cells that are used are typically the bacteria that we talked about, the fungal cells that we talked about, maybe mammalian cells that we talked about, right. They are used to produce products, and in the bioreactor the cells are subjected to shear. Okay. That is the next part of the story. We will stop here for this lecture, this part of the story. Essentially our story went something like this. We wanted to know what causes infection, and we said microorganisms cause infection, and we saw how microorganisms are organized for better understanding. If you look at those two videos, it will give you more reasons for organizing it a certain way and so on. Please look at those videos on taxonomy. And then we looked at the cell as the fundamental functional unit, and there being two types of cells, prokaryotes before nucleus and eukaryotes with a true nucleus. In other words, prokaryotes do not have a well defined nucleus, eukaryotic cells have a well defined nucleus. And then we saw that the cell is the fundamental functional unit of life. Then we saw that these organisms are present everywhere and started looking at how to get rid of them in an operation theatre. We looked at some means of getting rid of them, and then we looked at what a bioreactor was. Okay. Let us stop this lecture here. That was good enough new information for you. In the next lecture, let us take things forward with shear in the bioreactor. See you then.